All right. Can you hear me well? Yes, you can hear me well for sure. All right. People who sat in the last row through the previous presentation. Could you read the code?
No.
No. Implement dynamic type in your apps. So people who cannot read small font would be able to use your app. All right, that was the introduction. Another thing that I noticed sitting in the audience today, such a cozy room, so many people, and we all here inside have our own shared topic. We can all talk about constraints, about package managers, about Xcode, and the world outside doesn't know about it. You go, you leave this place, you go to U-Bahn, and you cannot talk with anyone about it. So, really appreciate the meetups. Thanks for organizing it. All right, let's go. So, my name is Mike. I'm originally from Ukraine, and it's a complete coincidence that I'm talking today with other Ukrainians who've been just before me. Roman, thanks for the presentation, it was great. And I've been working in iOS since a long time, I just didn't want to say a number of years, so let's skip it. Since I mentioned that I'm from Ukraine, you might have noticed that something is happening. Sorry, it is not funny. So it's single not funny slide in this presentation. Your paycheck arrives today, so there are many funds that support people in Ukraine, and you could consider donating it. Thank you. And today I'm working here in Berlin at Delivery Hero as a staff iOS engineer, and we're working on the driver app for people who deliver orders. And my role is in mobile infrastructure team. This is what I care about. Swift Package Manager, and this is my core focus. I've been working as a manager before, and I tried different types of engineering careers, and staff iOS engineering is really good. Not many companies are offering this career path, so if you're a senior, if you're thinking about your promotion, consider going into engineering progression path. All right, and we're also hiring, by the way. So that's what Delivery Hero is. If you live, order food abroad, unfortunately there is no in Berlin, but still, in many countries, Delivery Hero delivers food, like Foodora, for example, or Foodpanda, or Glovo. So this is not the first talk that I have about this topic of SPM. I've been presenting in September Coca Hats about moving from Coca Pods to Swift Package Manager. So if you want to check it out, there's a video version. Thank you. And this is more of a continuation of the former talk. So we, in Rider application, moved from Coca Pods to Swift Package Manager. And I think one of the first questions on my former talk was, is it faster to build with Swift Package Manager? And find it's exactly the same time to build as with Coca Pods. It's literally exactly the same time. My pull request was merged in the CI, and nothing changed. Well, except of breaking setup for many people in the company. That's changed, definitely. So what's the benefit of using Swift Package Manager? Well, if you would read this post, you would know, but also I would give you a sneak peek. It helps you with modularization. You could have local Swift packages that depend on local Swift packages that in turn be like a part of your mobile application. And Xcode understands it well, so it's a first-class citizen, and for your packages you don't need to have an Xcode project file. So I know everybody loves it with project files. All right. So this talk is about optimization, and so far, of course, highest impact on the build time. Don't do this. Of course, was Apple Silicon. But still, build times on iOS are much slower than, for example, on web development. Web development tries really hard to make build times slower, but still. And it takes up momentum, pushes out of the flow, and of course, as mobile infrastructure, we want to improve it. If you haven't noticed, in Xcode 14, you could have a build timeline where you detailed every thread, and you can see the things that, for example, block, like this great plan build, like that lasts almost 20 seconds. Like, Xcode, what are you planning? Like, what are you planning? What's your plan? Okay. But if you look closely, you would see like the things that in the big picture takes build time. And I've discovered that out of 10 minutes of our project building, around half is spent building external SPM dependencies, right? So your networking library, snapshot testing library, SPM just fetches the source code of it, and it's built every time. So every CI run and every clean build run on developer machines. So this thing doesn't change as frequently, right? And Insanity is doing the same thing over and over again, expecting different results. So why rebuilding it over and over? Makes no sense. And obviously, like, same input and same process should give you same output. We essentially catch the build results, and you would ask me, like, wait, this is Bazel, like, it's invented, just use it, so go home, that's it. But the thing is, I don't want to move from my build system, which is my cozy, supported Xcode build system, to the one that maybe would move my team from comfort zone and everything. So let's try to achieve it in the world of Swift Package Manager with existing tools. And you might have seen this before, right? So if you worked in the iOS, you've seen this before, and it's basically called Carthage. So Carthage allows this. You can attach binary releases to GitHub releases. Carthage just fetches them, puts frameworks in the right place, and you can use them. So why wouldn't we use it? We would exactly use it. Okay, so basically, your dependencies don't change that frequently. It is absolutely fine to put them additionally in a cart file. Ask Carthage to build them to XCFramework format, and use gitlfs to package it. Then, on your first build, you just need to unpack it once and let SPM understand its structure. Question might rise in the audience at this time. Aren't we using now two package managers? Yes, but you'll see, you'll understand it. Let's get building. So maybe some of you are not familiar with Carthage. Again, you just list your dependencies with the URL to Git and the version specifier. Then you need to install it, of course, and there's a special key saying use XCFrameworks and platforms. So, for example, you can use iOS. That would make Carthage either fetch pre-built XCFrameworks or build them from source on your machine. Then Swift Package Manager supports binary targets. So you could write or define a package manifest that would basically give you like a library and its binary target together. So SPM would know that in the package contrib, there is a product called Alamofire that would be built from the binary target. Essentially, you get the following folder structure, where you just have like a bunch of XCFrameworks and one package Swift. So that's it. Then you compress it with your favorite compression and put into GitLFS, which essentially works great when you package it, and when you want to use it, you want to do the opposite, so pull it from GitLFS and unpack it. Then, in turn, you want to reference the fact that you're using those frameworks from other Swift packages locally. So for this, you can just use a package based on path, and in your target specify dependency, for example, SD web image view inside of package. In our case, we call it contract. As a bottom line, so result of this exercise, we shaved off around 4 minutes from our build time, which is really like big change for us. I think originally we started with build times around like 30 minutes, then we went to 10-15 within one, and now we're in 6 minutes. So when you do a pull request, between 2 to 7 minutes, you will get the feedback, which really keeps you in the loop, keeps you engaged with your contribution. Additionally, it really saves money on CI. CI doesn't have to run that frequently, so they don't have to have that many machines spinning. And it's faster to build project locally, and you're really satisfied for not rebuilding Firebase over and over that consists out of like ton load of C++ libraries and stuff like this. All right, so this is, I'm very generous. I already prepared questions for you that you would ask. So, shouldn't we just use cartridge then, right? If it offers the awesome features. I don't think so, because SwiftPM, again, is a first-class citizen in Xcode, so you can have all the features, you don't need the project files, and yeah, again, it's a matter of taste, of course, so I think if you're already using cartridge, you're already good, and also you don't need this whole presentation altogether. And you might ask why use XCFramework format. I'm sure already many people know, but it's supporting shipping same architecture for different SDKs, which is like IRM simulator versus IRM iOS device. And if there are any additional effects, basically this would be dynamic frameworks then, right? So SPM by default creates static frameworks, which is has pros and cons, of course. So if you have many targets that depend on the same framework, it's better to have sometimes dynamic framework. For example, your, I don't know, home screen extension uses networking library and your main app uses networking library. You just have one dynamic one. And normally static libraries, like comparison between static and dynamic application startup time is faster on the static libraries because they're already linked, so Linker doesn't have to relink it when the app starts, especially on the first run. And there's additional effect. Sometimes you need to rebuild to use debugger properly, but I think we're close to solve this problem by having the proper build time flags when we build the XCFrameworks. All right. Thank you so much. Thanks to our organizers, and I'm open for questions.
Thank you, Mike. Questions? Yeah, thanks for the presentation. Like
Are there any Carthage users as well here? Okay, we got one. Nice. Awesome. I would ask, do you use some custom configurations when you build Carthage XCFrameworks, or you just build whatever Carthage is building? Because how else do you choose between static and dynamic linkage?
Good question. It just worked out of the box for me, and I think Carthage per default creates dynamic frameworks. By the way, there is the same library, I think, similar library for CocoaPods binary cache, and Twist exists as well, which is also like a, I think it's more than that, but it also allows you to manage dependencies and pre-build them.
Okay, but you can make it static if you want.
Might be, if I would try.
Okay, and one more question. You mentioned modularization, so which means you have a project which most likely have 10, 20, 30 frameworks. Have you considered to pre-build those frameworks and use something like not Bazel, but for example, XC Remote Cache by Spotify or any other similar maybe in-house tools to build those frameworks, cache them, and share between the team?
I think we might end up there eventually. Right now we have monorepo that has all the frameworks together, and again, like 6 minutes called build time is pretty good, I think. If we would get over 10 minutes again, this would be the way to go, yeah.
Would you consider using SPM directly in the checkouts that you get in the temporary folder? Because if you define a package as a dependency, it gets checked out into a folder, and then you could use the Xcode build directly to build the XC framework, and you would not have the dependency on Carthage.
Good point. Some frameworks work this way, I think, and I think, like, I cannot 100% guarantee now, but I think I experienced problems with, especially like big frameworks like Firebase, that has quite complex setup.
Yeah. Okay.
Thank you for the presentation, it was very nice. I remember from last time you showed some tools to detect the scope of the changes. Does it help you still to even increase it even more than 6 minutes?
Yeah, that's why I said in the beginning that build takes somewhere between 2 to 8 minutes, because CI spins up. We usually do an optimization in the way that we analyze the change set and associate the change set with change targets and change packages. And through the dependency graph, we could infer if change affect, like which packages are affected by the change. So for example, like, let's imagine we have a network package that every other package depends on. And we have a package for home screen. If we change the home screen package, we only run tests for home screen and the main app, but not for the network. And if we change network, we run all the tests because everything depends on it. That allows us, like, for example, if something changed that doesn't belong to any target, CI would like put a comment on pull request that CI didn't execute any tests and would end up like finish execution in 2 minutes.
The best time is 2 minutes, right?
Yes, because we set up like all the prerequisites first for build. I mean, it could be further improved, of course, to, I don't know, seconds, but it's rare to have a pull request that really doesn't change code. So normally this optimization allows you to cut many unit tests, but not cancel the build altogether.
Yeah, anyways, that's very nice. Thanks.
Thanks for the presentation. You mentioned CocoaPods and binaries already. And I'm curious if you went directly for Carthage or if you tried to and compared maybe the solutions.
It's connected a little bit to politics, because 3 months ago I moved from CocoaPods to Swift Package Manager. and in 1 month saying, okay, folks, like, let's move back. But I mean, I'm not a big fan of Cockabots. I think they do the job well, but I not enjoy them that much. I can go in details, but that's my.
Thank you for the talk. Since I'm the only one who raised his hand about Carthage, we actually use the same approach that you did a few years ago, started using that, using Carthage to read the binaries and use them through SPM. And we had really nice results, like from 25 minutes to around 7 minutes. With M1, we're at now 4 minutes. Our team actually lead the changes that we merged in the SPM package repo to use zip files instead of XCFrameworks. So now you don't have to actually zip all your package. You can just use a zip file directly and it's gonna work. Now my question is, how do you manage to solve the issues of dependencies that doesn't support Carthage? Or you did face that issues? We had some React Native stuff, we have some amplitude, I guess, or some snapshot tests. I think in the latest build they don't support Carthage anymore. So you import them manually, or you still use Cockabots?
So this is why I like meetups. I also learned something. Here we go. Basically, I tried framework per framework, if it works or not. And if some framework doesn't work, I usually put it back in the queue, then try again in a couple of days. Or maybe try a different version. I actually moved one framework to add SPM support. There are some frameworks that, like if you read the integration manual, there's a special manual for Carthage that says, just use this very special URL instead of our Git repo, and this will give you a list of like zip files for every framework. So I had to do this for a couple of frameworks, and there's been, I think, 1 or 2 like very obscure frameworks that we still integrate through Swift Package Manager directly. So you just added an Xcode as dependency, and it still works because it's all in the SPM world.
Hi, thanks for the presentation. I have 2 questions. Basically, the first one is, correct me if I'm wrong, but if you use SPM with Xcode, it creates its own cache system. So what's the benefit of using this approach versus the native one, let's call it?
Good question. So there are 2 layers of caching, I think, that you can take into account here. One is the repository checkouts. Those we cache on the CI. So Bitrise is very easy. Just say like, save this folder to cache. This works really well. So I think this adds additional speed up to SPM builds for sure. The thing with binaries, so we try to do the same for SPM binaries, and SPM was still rebuilding things. So I think it considers the binary cache outdated and discards it, even if you save it on one CI run and restore it on another one. But I think there's like a room for a feature on SPM. There's like Apple person in the room, or maybe listening to this presentation on YouTube. Maybe it's already implemented. Who knows?
Yeah, that's related to my second question. That's basically the CI agent cloud company, whatever you use. I did it on GitHub Actions and Bitrise, and basically using their plugin for cache, we saved 38% of the build time. Just using their own plugin. I don't really know what does behind the scenes. I guess it does some checks and commit and stores in some local cache, but then when you reinitialize the virtual machine, checks the package result doesn't have any new change, and fetches the cache.
Yeah, as I said, this works for checkout itself, but not for build artifacts. But checkout takes a lot of time on SPM, a lot. Because, okay, I bashed Apple last time, there was Apple employee in the room and he was like, this is not correct. It wasn't correct though, so. Basically SPM doesn't have a package index yet, and therefore in order to resolve versions, it has to do a full checkout of repository. If somebody ever committed really big file to repository, then it would end up on your machine. So I think we had like a couple of libraries that checkout is over 1 gigabyte.
Great talk. I'm not a for cartridge, I'm just not using it actively right now. So usually when adding like dynamic linking schemes into what is otherwise a static dependency tree, I found that you oftentimes stumble into a situation where you're linking against the same Swift package from those different now dynamically separated executables, which now contain the same statically linked package. So, for example, we have a situation where we also had a dynamic linking scheme, but both of them depended on Swift log, which was then triggering of duplicate symbols. And it seems like this approach is very prone to this, of course. I wonder how you deal with this.
I think we're, like, since it's modularized, it's either one of the modules that depends on external framework. And I mean, we only do this for external frameworks, right? It's either a module that depends on it or a main application. I think if it's a main application, then there is no issue. And if it's a module, the issue would arise if multiple modules would depend on the same dynamic framework. For example, we'll use Firebase from one module and from the other. But I think, so it did happen for us, for reasons most likely that the modules usually encapsulate use of the certain frameworks, and therefore they are, you don't have two modules depending on the same dynamic framework. But it's a very good point. Thank you.
In one step, you are compressing the packages, right? Dependencies. I was wondering, I imagine that there has to be a way to take a compression method where you would say higher compression time but lower file size and vice versa. Do you think, have you considered this option? And if not, do you think this is worth investigating?
I experimented with this. So initially I was thinking, okay, let's pick the fastest encryption possible, compression possible, because we don't care much about the size of the LFS file. It would be just quickly checked out and streamed to the CI. But it came out that not every engineer has that good internet connection. And especially when you need to upload the new version, the connection is usually asynchronous. So upload takes really much longer. So I think tar zip compression with like zero compression for our checkout would produce around 700 megabytes. And like with average default compression, it would be around 300. But the compression time difference is really not significant. So default compression works okay.
More questions?
Maybe just a stupid one. Why would you go for compression at all? Why not separate files?
So as a person from audience noticed, it would be possible to use like, as far as I understood, would be possible to use here like alamofire.framework.zip. So I think this would be our next step. This would make much more sense. If we would not compress at all, then we either need to use different type of storage. So I think GitLFS, at least for me, is associated with like big files, and in this case we'll have like many average files. So my initial instinct was to go for compression. I have some experience with caching on the CI, and I mean most of the times it's just using S3. So it uploads like just one big blob and fetches big blob. Instead of doing like multiple requests for each file, it does like one big request. So my thinking was like maybe it's better or faster, but I haven't really tried to just completely committed to the repo and see what would happen.
A lot of files in the XCFramework folder. There's like source, header, which is like quick review, the git history, just committed steps. But I'm not sure how it works with the
But I don't think there are stupid questions. So there are surprising things with CI. Sometimes CI works in surprising ways.
Also, you have to compress anyway because you include zip in the binary file.
True, yeah. Need to zip it anyway.
Thanks. Thanks for presentation. So, my question is more about Carthage. I had good and bad experience with it, but one of the biggest problem with versioning that let's say you have a Carthage binary and one developer changes by public API, say rename one parameter. And the client doesn't detect it because you can compile it and it will crash just on runtime. Did you experience such issues? How do you resolve them?
I'm very conservative. I'm very conservative. If there is no reason, I would never update the library. Worse, we are not on the web front end here. We're not on the back end. If library works, good old library would continue working, and that's it. But I mean, okay, jokes aside, I mean, you can always convert it to use again, like a dynamic SPM setup, and then I think SPM could resolve versions relatively well, at least in my experience. Yeah, and I mean, again, this is only for external libraries, so usually even if my conservatism is broken and I have to update library, I usually go and check the release notes. Release notes usually include like if there was a breaking change, and I mean if it's depends on which library, of course. I would strongly consider like not using libraries that do random changes in minor versions. So it's more of a like it's a two-way street, right? As a library vendor, you want to improve your library and change it and make it better. But there are people like me who don't never do changes and not expect any changes. So thanks.
Yeah, just as an input, if you were to use individual zips, you could put them in an SG bucket, and then there's a overload of the binary target that also has a checksum. So then it would only check it out once, and only if the checksum doesn't match, then it would give you an error. So you could have a script that basically runs Carthage once, uploads them to S3, and then you would just need to like calculate the checksums and update this file. So you then have a cache, a remote cache.
Very good point. Very good point. If there are people who work in big companies here, okay. How much time it takes to create a S3 bucket?
It's politics, right?
It's live. It's live.
Just put it on Linux. Yeah. Okay.
Thank you very much, Mike, for the presentation.